This is the homework for, let's put me in the middle here, for lesson 51. And doing echolocation with the Arduino. Okay, Paul set us up to showed us how to actually get the echolocation work on that little module. Okay, so what I've got here is if you go up here, I include SPI, wire, Adafruit GFX, and Adafruit 1306, which is for most part only required for the display. Okay, then I defined the OLED display. Yeah. Okay, and I called it Adafruit 1306, and I set up the display. So display is called display, and this sets that up. Now we have the trigger pin, the echo pin. I used 12 and 13 because it was convenient. The thing was already set up that way. Okay, and I have ping time, ping travel time, ping travel distance, distance to target old, distance to target new, and distance to target filtered. Okay, then I set up two DT times at 20 milliseconds and 25 milliseconds and 20. Okay, if I come down here, here's where we set up our pins. I set the pin mode for the trigger to an output and the pin mode for the echo pin to an input because it's receiving signals, and the trigger pin output is actually initiating everything with the display out or the chirp out. Okay, here's some more stuff for the display. As I cleared the display, then I also set up uh, serial monitor. Now down here, let me go back first of all and describe to you first that I've set up the distance. Can you see that? I got distance equals rate times the time. And here I've got the distance 765 miles to over 1 hour, which gives me a 1 down here. And then I have 5,280 feet with 1 mile. Okay. Then over here I got 1 foot and 12 inches. 3,600 seconds equals 1 hour. And then we have 1 million microseconds equals 1 second. Or that should be 1 second. Anyhow, I go down here and I drop all the what do you call it? The identifiers like the miles and feet and inches based on like with 765 miles, 1 hour. So 1 hour is going away because I have 1 hour up here. That becomes 1. It goes away. 5,280 feet has a 1 foot down here and it goes away. Then you have 12. Okay, then we have 1 mile and what's the other one? Okay, here it is. You got 1 hour and 3,600 seconds. And over here you get the 1 second equals 1 million microseconds. Okay, now if you take all those things that equal 1 out, you end up with inches and microseconds. So 765, 5,280, and 12, 3,600, and 1 million. You multiply these things out, and that's what you're going to put into the formulas for the calculation and the conversion. Okay, let me get this out of the way. Okay, now I don't know if you can see that or not. Yeah, not very well. Okay, let me just bend this thing down a little bit more. If I can prop it up. I would love to have. I don't know if you can actually see that or not, but I use bigger text, but it's a little sketchy here on my monitor. Okay, here I've got an OLED display, says distance equals 2.7 inches. And I've got it set for about 3. And I've got this thing, I got to set it up for, see if you'll see, I got 0 on this line. And inside here, the emitters are back a little ways. So if you move it up to where the emitter is and set it on 3, I got a little too far up. Okay. We're almost there. Come on, give me 3 inches. Here's 1 inch. Seems to be pretty close on that. 2 inches. It's said 1.5, so I'm not quite sure what that is. Oh, there it goes. I have it a little crooked, that's why. Something's a little crooked. Anyhow, if I go back out to 3 now, about as close as I get to 3 is 2.7. There it is. Okay, anyhow, I adjusted to the back of the emitter so that you get a little more accuracy. All right, now let's go back to the software real quick. Okay, here we set everything up for inputs and outputs, and I set up the display, and I clear the display. Then I come down here, and in a loop, I write the trigger pin low, delay the thing for 10 microseconds, and then write the trigger pin high, and then delay the thing for 10 microseconds, and then I write the trigger pin low. And then we'll ping the travel time equals the pulse in from the I don't know what you call that stupid module, but the little UltrSonic module. So you get that pulse in, becomes your actual measuring. I got the oscilloscope, but it's going to be hard to turn the camera and look at that. But I should say Paul showed that already. So in this case here, I've got the pulse travel time now. And then if I go down here, I got ping travel distance equals the ping time times 765 times 5,280 times 12 and divided by 3,600 and 1 million. And that all equates to inches. Okay, then we come down here and we take that the distance becomes that divided by 2. Then I've got the target filter. And what I did was I used a low pass filter to make this thing a little bit more stable. Like what you do is you take the filtered equals 0.9 times the distance to the target plus 0.1 times the target distance to the target new. So every new one you get, it's going to come in here and be this is the old one. That would be the new one. It works right well. And then we have here's some more text stuff for the display, which I don't think we've gotten into yet. Okay, here's my text size. I try to make this thing big enough so that people can see it, even though it's not really coming out that well on the display. Anyhow, I print the distance for the target filter. In other words, once I went through this low pass filter, everything becomes a little bit smoother. You don't get all that jumble and noise. Okay, then down here at the end, I clear the display again, and then I take the new target, and I make it equal to the old target, and then go back up here and start again. It goes back up here and goes right back down through the loop. And you can see right here, you can see that I got about 3 inches on there now. I can go back up to 2, like 1.9 and 1. And I go about the best I can get is about 0.7. It won't go much lower than that. If I bring the sucker out to 5, I get about 5.1. So anyway, there's my homework, and I appreciate you doing these videos, Paul. And we will see you on Tuesday. So,